These three equations we will solve using the square root property or method. In our first example, we first divide both sides by 4 to single out x squared. And now we have the arrangement that allows us to use the square root property. We have the whole part squared and a positive number here, so using the rule we can write x equals plus minus radical 3, and because this is a prime we cannot do anything. This is our final answer. In our second example, we first get 9 on the other side. As the second step, we divide both sides by 5, and we are doing this in order to obtain y squared on the left side, so we can use the square root method, because 5 is not a perfect square, so we really cannot claim that the whole side is squared. And now we are going to use the rule, and after this we can, using the quotient rule for the radicals, separate the numerator and denominator and place them under different radical signs. And also, since we see that 9 is a perfect square, it comes out as 3, but we still have radical 5 in the denominator, and we need to rationalize that denominator by multiplying both by radical 5. So the final answer becomes 3 radical 5 over 5. This is our final answer for this problem. Next problem. We already have the whole part squared, so x plus 6 is our u, and u is squared, and we have a positive number here, so we can apply the property right away and write that this is equal plus minus radical 25 or plus minus 5. So now our equation looks like this. But we still need to obtain one positive x, so we divide our space, and the first linear equation that we need to solve is x plus 6 equals 5. The second equation we need to solve the same, but equals minus 5. And when we solve this equation, the answer becomes minus 1. And when we solve the second linear equation, the answer becomes minus 11. And this is the roots of this equation.